All right, everyone, welcome to session 6. It is 6:17 p.m. Central Time. It's Thursday, August 24th. So this is going to be the last session of week 2. So congrats on making it through the second week of this. We're almost 2/3 of the way done. We don't have a whole lot of slides tonight. All we're going to do is talk about higher order functions. And we're also going to lead off with the solution for the illegal word types. And I think I had talked about it with the remove zero, or I'm sorry, the alphabet code, how we could look at basically like extending these basic algorithms to make them better. And so we'll probably solve this. We'll go over the two solutions because, like I said, there's a really easy built-in solution for this. And then there's going to be a more challenging, more in-depth solution that forces you to use a loop. And then we'll talk about a couple other things, like if someone gave this to you as an entry-level coding challenge and you just flash through it in a couple of minutes, like some of the things that they might talk to you about next to see if they could push your coding abilities a little bit. So let's go ahead and get started on the solution for this. I'm just going to go over our prep here again real quick, which is we're going to have two parameters here. They're both going to be strings. One is going to be a sentence that we need to search through. And the second one is going to be a word that which is also a string that we're going to search for. We're going to return a Boolean, true or false, if the sentence contains the word. We've got 3 examples below here, and we'll probably write out some more examples. And then there will be multiple ways to solve this. So we're going to do it with a built-in, and then we're going to actually, I'll probably do the loop first, and then we'll do the built-in. And then one of the things that's in the description of the challenge is it says capitalization should not matter. So we need to figure out how to make our solution here case insensitive. All right. So first things first. Let's go ahead and get started. I want to make sure that I'm getting both of my parameters here. So let me adjust my computer a little bit. And so we're going to just do a console.log of our 2 parameters, right? So sentence and word, right? So it looks like we're getting everything here. And now I need to figure out how I am going to iterate through my sentence. All right. And so we did this in one of the challenges yesterday. So we could take a look at doing a split, and we'll do it on every space. Right. And now each word in my each word in my string is now a string that is an element of an array. Right. And so now that I have that, I can start to iterate through my array and check to see if the word is, or if my illegal word is contained in there or not. Right. So let's go ahead and we'll say let r, or we'll just call it array, equal sentence dot split. And now we're going to go ahead and loop through our array here. And this time I will use a for in, which again, I don't write these very often. So let me just scroll back up here to make sure I get the syntax correct. Section 1, functions, control flow, iteration. All right, so it's going to be for let item of, so it's a for of loop. We'll say for word of array. And let's just go ahead and console.log word here and see what we get. All right, that looks like we're getting what we expect. And so now we could say console.log word. So we don't want to call it word because we've already got the other word. So let's just call it, we'll just call it W for right now. And I'll think of a better name for that. And so is W triple equal to word? All right, so we got some falses and we've got some trues in. Okay, so we know that we're hitting and missing depending on what's going on, right? So like hello there, just to make it a little bit more readable for right now. All right, so false, false. And then we're getting a true here at the end. I'm not sure. Oh, it's because there's a bang in here. And so this is actually returning false, but then it's saying true for the purposes of the test, which is silly, but we'll leave it for now. All right, so we're good. And that's just because it's returning undefined. Let's just take that out for a second. All right, undefined. That's less confusing. So now we can do something like this. We can take this out of the console.log and we say if W is equal to word, return true. All right. Now we don't need an else with a return false in here, because what we want to, like, because if we did an else and then a return false here, what would happen is on the very first word that we iterate through, so on hello, the word of the array is not equal to, let me just do this. We'll call this illegal word. And we can call this word illegal word. That makes more sense. So the very first time, so we check fudge against hello, it's going to go to the else case, and then we're going to return false, and then we're not going to check anything else. So even on this one, we would check fudge against the word but, and it's going to return false. So we don't want to return false just because it's not in there. What we want it to do is check every single word in here. And if it finds it, we can stop looking, we can return true. If not, we can keep going. And if we make it through the entirety of the for loop without hitting it, then we know we can return false. All right, we can go ahead and run this. Word is not defined. Word of array. Right, so we made it to false, and that's what we're returning. So we can take this and we'll put this back in here. All right, and so we pass the test. It's true. All right, now same thing for these two. All right, we get a true, and then lastly we get a false. And so we have a problem that we're not being case insensitive at this point, right? Because fudge did not line up with fudge. So what we need to do is basically take both the sentence and the illegal word and send them to the same casing, right? Because if we only do one of them, right? So if we say two lowercase, right here, and we can run this and we'll get true. But if we then take this test and we write the reverse of it, where we say this, now we're back to false again. So we need to take both the sentence. So then we're going to do two lowercase right here, and then we're going to split it, and then we're going to do the same thing, and now we get true across the board. All right, and so this is how I would solve this using a loop. Any questions on how I did this? Right, and if we did this as a for loop, that's how we would do it in a for loop. So you can see, because we need to go through the entirety of the array each time, you can see this is a little bit easier to read. All right, and if there's no questions in here, if I were to solve this in, again, say a production level problem here, what I would look at is I would write this most likely as a single line, right? So I could say return, and then we could say sentence. to lowercase dot includes the legal word to lowercase. Right, and so we've replaced our loop and we've used a built-in, which again is looping through all of the index or all of the elements in the array. It's just doing it all behind the scene for us in a built-in method. And then we lowercased it, and then we took our legal word and we lowercase that as well. Right, and so if you were to walk into an interview scenario where they hit you with this and they said, hey, solve this for us, and you go, okay, that's easy, I'd use this built-in, this built-in. But the next question would most likely be, okay, how do you solve this problem without using dot includes? Right, and then if you solve that, then maybe they would throw something into you that would be a little bit more challenging, like, okay, can you solve it without a lowercase? Right, and then we could use that char code at that we used yesterday to identify if it's an uppercase or not, and if it is, to replace it with the lowercase version within it, right? And so like we can progressively make all of these challenges more and more challenging to basically push where you're at. All right, so any questions before I wrap this up and I move into the slides for session 6 tonight? All right, so higher order functions. Functions that operate on other functions, either by taking them in as arguments or by returning them, are called higher order functions, right? And we actually did something like this similar, I think in one of the examples on the very first night, we just didn't talk about it being a higher order function, all right? And so if we look at, we can write a couple of functions here. We'll say let add equal AB fat arrow, right? And remember, this is the same thing as saying function add AB, right? So those are the two same things. This is just using the newer syntax. And so then we can say return A plus B, right? And then we could say let multiply equal AB right? And so now these are just standard normal functions, right? Like this they both take in two parameters. We're multiplying two numbers together. So we could say something like console.log add 510, and we could say console.log multiply, and we'll say same thing, 5 and 10. All right, we run this, we get 15 and 50. So everything's looking good there. So now we can take a higher order function, which again is a function that either returns another function or takes it in as a parameter, right? So we could now say let calculator equal A, B, and calc, right? And so now when we call calculator, we could then say return calc AB, right? And so now what we're asking for is we're asking for our two numbers and then the function that we want to use, all right? And then we're calling the function that we feed into it. So the function can be a parameter as well. And then we're giving it the two numbers. So if I just comment these out here real quick, and I say console.log calculator, and I say 5, 10, add, right, I get 15, right? Because what happens is up here, A becomes 5, this becomes 10, and this becomes add, and then we pass it into the function, and this becomes add 5, 10, right? And so just like we did it down here, and same thing, if I change add to multiply, I get 50, right? So I'm actually passing the function in to the parameter as another, or I'm sorry, passing the function in as a parameter, and then I'm also returning the function and giving it the other parameters, right? And we could continue to expand on this. We could do divide, all the other different functions of a calculator here, right? And we do this to help keep our code organized. Right, so same thing here, add, multiply, feeding it in, we return the answer, right? So they just called it, instead of calculator, they called it, and this should be multiply, this should be, and of course, all right, so there's that. And then it basically converts it over to this, to here, and then we get our answer, right? That's all there is to higher order functions. Some of the challenges that we do towards the end, you could probably use a higher order function, but it wouldn't be necessary. It would just help your code be a little bit more organized. And then you'll really start to get into this when you get into object-oriented programming and you start dealing with what are called classes, which you use to help keep your methods organized. All right, and that is it for the slides for session 6. So like I said, as class goes on, there's less slides, there's less talking. There really aren't even any slides. So session 7, we're going to talk about truthy, falsy, and recursion. Session 8, Greg already covered most of it, and we're going to talk about what the full tech stack looks like at Code Platoon. And then session 9, there are no slides at all, right? It's a review session, and we can hit some of the harder challenges in here. But if there aren't any questions on what we just went over with higher order functions, we can pick our first challenge for the evening and we can get going. Going once, going twice. All right. So we just finished up with a legal word. All right. Can I go to the bar? No. What is your grade? No. Cold enough is buzz. Let's do caffeine. So I think for tonight, what we'll try and do is the caffeine and then fizz buzz. And then if we still have time, we'll do detention. And those will be the challenges that we go for tonight. There is the link to that. All right, so let's go through the prep together, and then I'll break us out into groups, and we will we'll give probably like 20-30 minutes to work on this, and then just depending on how the groups are doing, and then we'll get back. And then when we do fizz buzz, we'll probably leave a little more time for that one. And fizz buzz is a really common interview question. So, all right. we've got every weekday you drink caffeine to get ready for the morning. Monday, you need 800 milligrams to wake up from the weekend. Tuesday, you only need 600 milligrams. Wednesday and Thursday, you only need 400 milligrams. But on Fridays, you drink 900 milligrams because you know you'll be staying up late and going out with friends. You prefer buying small energy drinks that contain 150 milligrams of caffeine each. Write a method that takes in the day as a string and returns the minimum amount of caffeine drinks you'll need to buy. All right, so we're going to have one param coming in, which is a string that represents the day of the week. And we're going to return a number. All right, how much energy drinks you need. We've got some examples below. All right, so I need to build some sort of data structure or control flow that will allow me to identify how much caffeine All right, so let me go ahead and drop this into the chat. And as always, there's going to be a couple of different ways to solve this. Pause the recording. All right, everyone, welcome back from the caffeine challenge. And it is 7:07 p.m. So we're going to go ahead and go over the solution to this as a class, excuse me, and then we'll take a quick break here and then we'll get into the next challenge. All right, so as I was saying, multiple different ways to solve this. We could take a look at control flow, right? So we can use a if else, actually it'd be a if else if statement, a switch statement. We haven't talked about those in class yet, but we'll do it. And then we could also do an object here, right? And that's not control flow. All right, so let's go ahead and take care of it as an object first, and then we'll move into the control flow. All right, so we could do something like this. So we could say, let drinks needed, right, equal, or actually we could just call this caffeine needed. Right, and we could do something like this and create an object, and we could say M is, what did we say up here, 800, right? And then Tuesday is 600. Wednesday is 400. Thursday is 400. And then Friday is 900, right? And so we could then, from there, we still need to do some math, right? So we could basically say return caffeine needed box day, right? And before we hit the return, let's actually throw this into a console.log real quick. That, let's make sure we're getting what we think we're going to get. Right, so 800 and undefined, so because I did Thursday and they're doing Thursday. All right, so there's our 800 and our 400. All right, so we could then, we'll take this back out of the console log, we'll change this back to an R, right? And then we could basically do something like this, where we need to divide it by, I think it was 150. And this would be the next step in it. This, though, will probably give me some fractions, I believe. Oops. Right, so I'm getting these and I need whole numbers. And when we've dealt with something like this before, we use like math.floor, or we just used like parse integer, and that just chops it off. But we need to actually round up in every instance, because if we only need like 2.1 cans, we have to go out and buy 3 cans, right? Either that or crack a can open in the store, take a sip and run. So let's look at JS, how to round float up. All right, so we've got round, we've got floor, we've got seal, right? So which is probably sealing. Do we got anything in MDM? Let's look at MDM number. Methods. I don't see a dot seal in here. I'm not sure if that one is, if I was pulling that up for a different language. Okay, you're saying it's part of math. So let's go ahead and take a look at that then. So we could say math.seal JS. All right, so there's that. That looks pretty good. All right, so 0.95 goes to 1, 4 stays at 4, all the way out. We go up to 8. Right, if we got a negative number, we're actually bringing it closer to 0. So when we do math.seal, we can, sorry, control flow. We can take this whole thing and we'll wrap it in here, right? And so we'll call on math, and then we'll call the built-in function on it, right? And so we should be good to go with something like this. Right, so I see 6 and 3, right? And then if I get rid of these, I get true and true, right? So this is how I would probably solve this one with a object. Mainly because I like the data structure. It keeps everything nice and clean in here, and I know if I ever needed to change any of these things, I could really easily. The next way that we could solve this would be solving an object, right? We could always do the good old-fashioned if-else statement, right? So we could say if day is triple equal to m, right? And then we could, and actually what probably would do is let caffeine, and we don't need to assign it a value yet. We could say caf equals 400, else if day triple equals Tuesday, right? Caf is equal to 600, and I know this is 800, not 400. else if day is equal to Wednesday, and we could clean this up a little bit and say or day is equal to Thursday, right? And we could say calf is equal to 400, and then else if, oh, we can just leave it as an else for right now. And say calf is equal to 900, right? And then we could return the exact same thing in here. Math.ceil calf divided by 150. All right, let's go ahead and run this. And we get our true again, right? So this is another way to do it. Now, one thing I would say though, and kind of the thing like, and again, these are very limited, but like the next thing I'd say is like, what happens if someone puts in Saturday here, right? Like, I mean, we'll get a false here, but what the issue is that if I were to, so 900, I need 6 cans that day. If I were to take 6 on this, put in Saturday, and I'd get true for this, even though this isn't really something that we're looking for. And it's because this else case catches everything, right? So I could say something like this, and if I'm looking for 6 cans, it's going to default to that 900 milligrams, and I'm going to get a true answer, even when it's not. So probably something I would do here to make this a little more accurate would be day triple equals F, and then calf equals 900. Then I could say an else that is not a valid day, right? Or I could return -1 or something like that. And now I could say this is not a valid day, right? And come back over here and let's replace our test where we're looking for R should be 3. Oh, still get a false. This is not a valid day. This is not a valid day. Why is this failing? So let's go ahead. Oh, because I'm still returning here, or not returning, I'm putting calf, which is undefined at that point because I never assigned it a value. And we could, I'm still getting false. So let's go ahead and that versus this. Yep, thank you. That was my next step. There we go. So real live day in the life of a coder today. I spent 30 minutes tracing back through my code because this is how you are supposed to spell the word separator. And I spelled it that way 3 times, and then one time I spelled it like that. And when that word is buried in hundreds of lines of code multiple times, it took me longer than I would like to think about to find just that misspelled word. But again, the computer will only do what you tell it to do. All right. And so we've got that out of the way. All right. And so this is now a little bit better, right? And we could do the same thing down here within the object. Like if we wanted to solve for this, we could say, if like, well, here, we can even do it. So we could say, solve with control flow, right? And if we come back down here and uncomment this real quick, we can do the same thing. So, whoops, don't want that. You can say, if caffeine needed that has own property what do we call this day, right? And then we can take this part, and so if it's in there, we'll return this, else return, just so I don't do the same thing again, we'll copy this. Right, so that is not a valid day. And there's all my trues again, right? So now we're adding in like some additional protection there. We're building it out, we're making this a little bit more functional. All right, and so lastly, and we haven't talked about this in class yet, but JavaScript does have a switch statement. And that is kind of, it basically does control flow. It's like an if-else statement where you can give it different cases, and as the cases match up, you can basically have it take different actions. Now, with a case statement, you will have a default clause, which is kind of like your else, like this is the catch-all. So if none of these cases get hit, and with a switch statement, they call it falling through, right? So if you don't have a break, it will continue on to the next cases, right? Or if you have a return, because a return kicks you out of the function anyways. But if you don't put these breaks in here, right? So like if we run this once real quick, right? Mangoes and papayas are $2.79 a pound. Let's go ahead and delete this break statement and see what it does. And it doesn't always break everything, right? So there we go. Now we've got, because I got rid of the breakdown here, we eventually hit the default, right? And it's the same thing. If I gave this oranges, right, now I'm hitting all of the cases because my break statements aren't in there. Now, because we're console.logging, that is why it's also happening. If these were return statements, you don't need a break in there, but it doesn't hurt. Like, well, I mean, your IDE will tell you if you need one or not, but always remember that you do need break statements, and that can be a trap there. Right. So now when we do it, we're back to working and only getting what we want. We call that falling through. Right. So your switch statement will find the first one, and if you don't tell it to stop at that one, it'll give you everything else for each case after that as well. All right, and so back over here, and actually let me just grab this here real quick. And we'll comment this back out. And we can call this one solving with switch statement. And just make sure I've got stuff here. All right, so I can get rid of this. And I do need my switch statement. Close in. And then we'll just call this day. Right. And so now we've got Monday. Right? And so what I would probably do here is, again, the same thing. So we could say let calf, and then we can say calf is equal to 800. Let's see here. What did I, oh, that doesn't get declared there. That gets declared here. And again, same thing here. If I don't put my break statements in, do case Wednesday. And I believe it was completed, even though I copied it over here. All right, so we've got a case, and when we don't put anything in here, what we're saying is immediately go to the next one. So mangoes and papayas are $2.79 a pound. So if you put in mangoes or you put in papayas up there, you'll get the same response, right? So we could do the same thing here and say case Thursday, and we can call calf 400 break in. U right here. So there's that break. And then we need one more day, case Friday, right? And cap 900. And default, again, same thing. And then do return. This. It's yelling at me, telling me this is unreachable code most likely. So how am I supposed to end my switch statement? That's fine, because I am probably inside this. Be right here, and now the world's a happy place again. Here's my closing one. And there are my trues again. All right, so all three of these are valid solutions for this problem. Any questions on a switch statement, solving this with control flow, or solving it with an object? All right, it is 7:25. Let me go ahead and pause here. All right, everyone, welcome back from break. It is 7:32 p.m. Central Time, Thursday, August 24th. We're going to pick out another challenge here, and I think we're going to jump into FizzBuzz. So I dropped the link for that in the Zoom chat already here. Go ahead and fork this. We'll fill out the prep together, and then I'll break you back out into your teams. And yeah, we'll probably give you a pretty decent chunk of time to try and solve this one. And then we'll come back and we'll go over a class. And like I said, if we've got time, we'll get into that third challenge for the evening. All right, let me pull this stuff over. Probably won't pull the instructions over this time. I'm just going to pull this over. You don't need to do it to 100. You can just do it to like 10 or 15, or actually, I guess you'll need to go past 10 for FizzBuzz. So we'll say we'll do it to 50. All right, so let's go ahead and read this. So the FizzBuzz test is an interview question designed to help filter out the 99.5% of programming job candidates. Sure, it's a rather serious number there, but this one does come up quite a bit. The text of the programming assignment follows something similar to this. Write a program that prints an object with a number of keys. The key is the number, and the value is either the number, fizz, buzz, or FizzBuzz. But for multiples of 3, assign the key's value equal to fizz instead of the number, and for multiples of 5, assign the key's value equal to buzz. For numbers which are multiples of both 3 and 5, assign the key's value equal to FizzBuzz. Otherwise, assign the key's value to equal to the number. All right, so we're going to get one parameter, which is going to be a number. And that's how high we're going to count. All right. And we're going to return an object, right? So that's our data structure, an object that will contain key value pairs of so a key as a number and a value as either number, string, is string. buzz or fizz buzz. I think we do these uppercase. Yeah. Right. And so example, we'll say see below and readme. All right. So with this, so we can see it here, right? So anything, so we're going to have an object. The key is going to be the number in the count, right? So this object will go from 1 to 100. And as we generate the key value pairs, if it's not divisible by 3 or 5, we get just the number. Right. And so 1, 2, and then 3 is evenly divisible by 3. So we get fizz. 4, 5 is evenly divisible by 5. So we get buzz. 6 again is fizz. 7, 8, fizz. 10 is buzz. So on and so forth. And when we get to 15, because it is divisible by both 3 and 5, we do get fizz and so basically fizz buzz. All right. And this pattern continues, repeating itself until you're done counting. All right. So all right. So let me drop this in over here. And does anyone have any questions for me before I pause the recording and send you out to your teams?
So when what we're trying to do, when we console log fizzbuzz50, we should get that account from 1 to 50 with all those
Yep.
with all of that.
You should get you should get an object 1 through 50 with key value pairs in it.
Okay.
Any other questions? This. All right, everyone. 8:10 Central. Welcome back from the FizzBuzz Challenge. We're going to go ahead and go over this as a group now, and we'll see what we can figure out here. All right. So again, we want to create an object, right? So our return is an object that will contain a key value pair of a key that is a number in sequential order 1, 2, 3, 4, 5, and a value as either a number, a string fizz, a string buzz, or the string fizz buzz. And so let's go ahead and get started on that. So again, we're going to solve this step by step. All right. So we're going to do console.log num to make sure that we're getting what we want. All right. And I know that I'm going to need an object here. So we'll just say let object equal an empty object. All right. And so let's go ahead and console.log object. All right, there's my empty object. So how do I get something inside an object, right? Like I know if I have an array, I need to push or I need to unshift. So let's go ahead and do a quick search here. So we can say JS, how do I add a key value pair to an object? All right, the most common and straightforward way to add a key value pair to object is use dot notation. You've probably already used this in the past. 30 seconds of code. Stack Overflow. All right, yep. So there's the dot notation. You object dot key 3 equals the value, or we can use square bracket notation. I like square bracket notation. So let's go ahead and give that a shot. Where is it? I'm gonna pull that all the way to the end over here. All right, so let's just go ahead and do object, and then we'll say 1 equals 1, and let's console log object again. All right, and there's my key value pair in there. Cool. So we know we're going to do something like that. We've got our object. So we know that we need to loop, right? So this could be because we're counting up and we're incrementing. I think this would be a good case for a for loop. So we could say for let I equal 0, I less than 50, and then I plus plus. And let's just console.log I. All right, so we stop counting at 49, right? We know that we want to go up to 50, and it looks like we start counting at 0. So we could do some adjustments to our for loop here, right? So instead of counting at 0, we can start counting at 1, and we could say less than or equal to 50. So let's go ahead and see what this does for us. Start counting at 1, stop counting at 50. So that looks pretty good to me. So the next thing we could do is take something like this. Can you guys hear my cat screaming in the background by chance?
I don't hear anything.
Yeah, a little bit.
I didn't hear
Sorry.
anything.
I'm getting my my house repainted, and so everything in my living room area is pushed into a pile in the middle of each room, and like they've got it covered with plastic, and I can hear him like running back and forth in and out of the plastic and screaming. So it's a giant cat toy for him. All right, so if I do something like this, right, and we could do that, and so there's the for loop, and we could console.log object again. All right, we don't need this one right now. All right, and I just get the one value in here because I've left it hard coded. So what I want to do is actually say I, right? Because each time I loop through, it's going to be a different number. And for right now, we can say this is I as well. All right, that's looking good. Now remember, even though we're giving it a number, we convert it to a string, or kind of basically what JavaScript considers a string behind the scenes with the key of the object. And then we've got our numbers, right? So we've solved the first part of this, right? Like, so we've got numbers going. So now we need to start making some decisions here, right? And if we want the computer to make decisions for us, we need to use the basic building block of control flow. So we can say if, let's see here, and what's a way that we can make sure that I is divisible by 3? All right, I mean, we could say, yep, so we could say remainder, right? 3, or so what some people call the modulus. So if I modulo 3 equals 0, we know that it's equally divisible by 3. So, right, like if I is 9, modulo 3 goes into it 3 times, there's no remainder, right? And so now we could say something along the lines of object I is equal to fizz, right? And then we'll take that out of there. Otherwise, we will end up with it too many times. And we'll say else. Whoops. No, that was object I is equal to I. All right, and then we'll spit the object out again here at the end. So we don't need to console, we can return the object. right? So 1, 2, 3 is fizz, 6 is fizz, 9 is fizz, 12 is fizz, 15 is fizz. So this is looking good. This is the next logical step here, right? And so now instead of it just going straight to the else, we could do else if I modulo 5 triple equals 0, right? We can then say object I is equal to buzz, right? And so we'll do that. And so we've got fizz, buzz, right? But when we get to 15, notice how we basically were just giving it a fizz, right? Like we don't get our fizz buzz. So what would be the next step that I need to do here following this pattern?
Have to check for both 3 and 5.
Sorry, you were very quiet there.
You'd have to check for both 3 and 5. So you can
Yep,
fit
check for
those
both.
together.
Yep, both 3 and 5. And what line would I put that check on?
That would have to be in the first if statement
And why is that?
because it's going to be the first one to execute.
Yep. So if I do something like this, else if I modulo 5 and I modulo 3. Oh, sorry, I need equals 0. 0. That. Bring the else back up here and then say object I is equal to fizz buzz, right? The same thing that's happening here when I hit 15 and I'm going into the first one, right? And so I never give it a buzz, like 15, 45, 30, all of those are all just going to say fizz because we stop at the first case and then we start our loop over again. We will never actually get down here, right? So nothing really changed here because we never reached this. And so absolutely great call. We do need to make sure that this is the first check in our if statement. And does anyone know a math trick that we could use to clean this up a little bit? So if something is divisible by 3 and is divisible by 5, it must be divisible by.
Divisible by 15.
Yep.
Yeah. Yeah.
So now we could do something like that. We'll clean this one out. And we'll just call this fizz. Right? Fizz, buzz, fizz, fizz, buzz, fizz, fizz, buzz. Right? 30s, fizz, buzz, so on and so forth. Right? So now we're looking good. And this is the solution. Any questions on what I did here?
So Charles, just to make sure I'm understanding, the most stringent thing that we have to check for in our control flow typically should be the first thing. Is that basically how I should think about it?
Yeah, you want so narrow funnels to big funnels, basically, right? And so you have to take a look out for something where basically if this one it's always going to stop at the first case, right? And this is our most specific case, is I remainder 15. And so we have to check for that first, because if it falls into one of our bigger buckets, like fizz occurs basically like every third number, right? Like it will supersede this. And so we always want to try and filter from most specific to least specific. Otherwise, some of your specific cases will get swept up in the lesser cases.
Okay, thank you.
Yep. Any other questions about this? All right, so nice job on this one. Let's go ahead and look at a third and most likely final challenge for the evening. And I believe I said we were going to do detention, correct? Oh, actually, sorry, before I fork it, let me give you the link in the Slack. Justin, no, with that, you don't have to switch the keys to numbers. That's just like the way the person who created this challenge typed it up, because you can't create them to numbers because JavaScript is always going to convert them back to a string no matter what. Right? Because technically, right here, this is a number, right? Like this is like I is a number. It's not a string or like a string representation of a number. I am giving it a number for the key, and JavaScript is automatically treating the key like a string. Right. And I think it talks about that. Um, yeah, I can't remember where I read it now, but again, the keys get treated like or actually, that's where I think we saw it was in keys. Yeah, the objects own enumerable string keyed property keys. Like, so that's what it treats it as. So it doesn't matter what you give it, it treats it as a string keyed property key. So, and I can clean that up in the markdown where I can go through these and basically put them all in quotes because that will be less confusing. But yeah, you don't have to worry about these being numbers because you can't make them numbers. JavaScript won't let you. All right, so I dropped detention into the chat. Let me fork it. Where did you go? Back over here. Fork. All right, let's do this. All right, so instructions. All of the students in the fifth and sixth grade have detention. You can tell a student is in the sixth grade if 6 is the highest number in their student ID. If the highest number in their student ID is less than 6, they are younger. And if it's greater than 6, they are older. The same rule applies for fifth grade students. Write a method that takes in a student's ID as a string of unknown length and returns a Boolean true if that student has detention or false if they do not. All right, so we've got one parameter, which is a string, and we're going to return a Boolean. All right, so All right, so let me grab this. I will drop this into the chat. Any questions for me before I open the breakout rooms back up? All right. All right, everyone, 8:56 p.m. Welcome back from the challenge. Looked like one group got it, the other group was close. So we will go over the solution to this on Monday at 6 p.m. when we start up class, and that'll be week 3 and the final week. So again, I know the study group is alive and well. I added another member to it. If anyone else is interested in joining it, let me know. I can get you added to the channel. It looks like they're doing some outside challenges. It looked like some Code War challenges in there. So some extra repetitions. And then outside of that, if anyone's got any other questions for me, feel free to throw them out there. If not, we're pretty much done for the evening.
Hey, Charles, I was gonna say, you can definitely add me to that study group.
Yep, for sure. Are you just Brian on Slack or what? Or can you shoot me a message and then I'll have your screen name and I'll add you.
What we'll do, I'm about to message you right now.
Sounds good. All right. Anyone else got anything else for me before I hit the pause on the record? All right.